The water depth, h meters, measured from the bottom of the harbour, t hours after 6 a.m., is modelled by the equation h is equal to 12 take away 4 cos pi t over 6 take away pi over 4 meters. Determine when the water depth is at its lowest in a 24-hour day from 6 a.m. and state the lowest depth. Now, a lot of the parts of this question may seem difficult, but remember, this is calculator assumed, and we can use all of the features of the calculator to help. So let's go to Graph and Table. And let's put this function in. Now we need to make sure we're in radians here. And we've got 12 take away 4 cos, then we're going to have pi x over 6 take away pi by 4. And select that, and then we can graph that. Now we're talking about a 24-hour day. So I'm going to say the minimum is 0 and the maximum is 24 here. And let's have y going between, say, -1 and 12 over 4 is 16, so let's go for 20. And then it looks like this. So where do we get a minimum? So we've got a minimum here when x is 1.5, and the other minimum is when x is 13.5. So we can say that t is 1.5 and t is 13.5. Remember, this is after 6 a.m., so 1.5 hours. So that's 7:30 a.m. And then again 12 hours later than that, so 7:30 p.m. We also wanted to state the lowest depth, and we can see that the y here is 8, so 8 meters is the lowest depth. We could have seen that from the original function, because of course we know that the cosine has an amplitude of 1, so 12 take away 4. Repairs to the harbour can only be undertaken if the water depth is below 10 meters. Between what times of the day can repairs be made? So let's add y equals 10 to our graph. So it's going to be beneath this line. So analysis, gsolve, intersection, and the first one here we can see is at 3.5. Notice it was below that depth at 6 a.m. as well though. So we can say 6 a.m. and then that was 3.5, so that's going to 9:30 a.m. Now let's go across and find the next intersection. So that's 11.5. So 11.5 hours from 6 a.m. is 5:30 p.m. And then that's going to stay below, and this is 15.5. So if 12 is going to be 6 p.m., that's going to be 9:30 p.m. And then if we carry on, we've got 5:30 a.m. until 6 a.m., which is when the whole day is over. And let's just make a note that that's the next day. The water depth is above K meters for 20% of a 24-hour day. Find K. So 20% of 24 hours is 4.8 hours. 4.8 divided by 4 is 1.2. Now, why have I divided that by 4? There were 2 maxima in the day. So, by symmetry, what we have is 1.2 hours here, 1.2 hours here, 1.2 hours here, and 1.2 hours here. Now let's just consider the first of these. So let's find the maximum. Let's just get rid of this graph and regraph it. And let's find the first of our maxima. And that happens at 7.5. So this would happen at 6.3. So let's see how high the graph is at 6.3. So analysis G-solve, we want a y calculation when x is 6.3. So that gives us the height of the curve there, and we can see that the height is 15.24. And that's K. K is equal to 15.24. That would be in meters, because we can see that it's going to be above that level for 20% of 24 hours.